Welcome to today's session on breaking down the monolith with Amazon Web Services. If you can't quickly and reliably deploy and operate software, most other concerns become secondary. G'day, I'm Bryn Price, a modernization solutions architect with AWS based in Sydney, Australia. I work with companies who are facing this reality of old legacy monoliths that are slowing their pace of innovation and impacting day-to-day operations. Today I'm excited to talk about moving from a legacy monolith to microservices, exploring approaches to incrementally decompose, the considerations as you execute on that transformation, as well as some of the AWS services that exist today to help. So let's talk about a legacy monolith and the challenges that it poses to organizations. A large monolithic application makes development more complex and slower. You can't scale individual components. If there's an error in any module, it could affect the entire application's availability. Of course, any changes in the framework or language affects the entire application, making changing things often expensive and time-consuming. A monolith is constrained by those same technologies already in use in the monolith. And finally, a small change to a monolithic application requires you to redeploy the entire monolith. So what does the other side look like? With a modern cloud application often deployed with serverless technologies. Well, with a number of loosely coupled microservices, development speed can increase, allowing new features to come to market quicker. As each microservice is in its own bounded context, innovation takes place without impacting other parts of the application. From an infrastructure standpoint, you can now scale these individual services appropriately, and moving to serverless can further reduce operational costs. Finally, a well-designed microservices architecture has mechanical sympathy, where a single failure doesn't impact the entire service. So you understand the challenges and the benefits that can be realized through modernization, but how do you get there? There are a number of decomposition strategies I see customers using, including event decoupling and domain-driven design, and it's important to understand that they aren't mutually exclusive. Today, I want to share with you a common strategy to help break down the monolith called the Strangler Fig Pattern. Martin Fowler coined this pattern after visiting our very own far north Queensland rainforests, where he saw how a strangler fig grows around a tree, slowly starving it of nutrients and sunlight until it was replaced by the fig itself. So how does that work for a microservice decomposition? Let's look at an example case. Here we start with our monolithic application talking to a single database. By initially putting a proxy or facade in front of our application, we're able to make changes without impacting customers. We then extract or rewrite parts of the application into a new microservice with its own data store. Over time, we decompose more and more microservices, shrinking that reliance on the legacy monolith. In this way, the monolith dies with a whimper rather than a big bang. Petco, an AWS customer in the US retail space, struggled with being hamstrung with the legacy technology in their monolith and embarked on a serverless-first decomposition of their monolithic applications. This enabled them to accelerate new features to the Petco app and website. I particularly like this quote from the project. Remember, this is a journey, and starting is the hardest part. Start by choosing something impactful and specific, and work to decompose it and iterate. So how do you start? How do you actually decide how to strip out functionality from the monolith? These are 3 examples that I recommend that align well to the Strangler Fig Pattern. Firstly is customer demand. This is where you take a look at the monolithic application and strip out or create net new functionality based on customer demands. If it's a net new capability that doesn't exist, you'd build that as a new microservice. If it's a feature request that impacts existing capability, you take that opportunity to strip it out of the monolith, re-architect, and point to the new service. Application hotspots are another great technique, identifying what's the most used capability in your monolithic application. Which part of the app is taking the biggest hit, and strip that out first so you can scale that component independently. Finally, you can strip out based on data domains. It's important to note that this is the hardest and requires you to have a good understanding of customer access patterns and what parts have what data ownership. Let's have a little look deeper at iterating on customer demand. In the middle, we have our monolith with various functions. Based on customer demand, we have a new feature to develop called Funds Watch List. Instead of developing this within the existing monolith, this is a perfect time to create it as a new microservice. As per the principles of microservices, each service should have its own database to ensure loose coupling. This means that each microservice has its own view of the data that it needs to perform its function, and it controls all access to its data. This is sometimes referred to as the database per service pattern. Now here we have a feature request that looks to uplift an existing part of functionality, in this case to provide a statements report for greater than 4 years. Instead of updating the code in the existing monolith, take this opportunity to extract this function into its own microservice. It may take longer to develop in the feature request. However, the long-term payback will be greater with microservices. Web server logs, ingested into a monitoring system, provide invaluable insight into the heaviest utilized areas of your application. By identifying high traffic pages and services, you can actually pinpoint which areas provide the highest value when refactored first. Prioritizing these areas can maximize your return on investment during that decomposition process. In addition, analyzing your application logs with an application performance monitoring tool will offer another layer of understanding to your application's behavior, performance bottlenecks, and opportunities for optimization. For AWS-hosted applications, AWS X-Ray offers powerful tracing and observability capabilities. By providing detailed visualization of your application's performance, X-Ray allows you to determine performance bottlenecks, hot paths, further informing your decomposition strategy. After migrating your hot paths to microservices, you can progressively scale down your monolithic application. For organizations that are currently operating a legacy monolith on-premise, I highly recommend a lift and shift migration to AWS as the first step, followed by gradual iterative decomposition into microservices. Moving to the cloud provides greater flexibility in terms of compute resource allocation. This flexibility allows you to optimize cost as you proceed with the decomposition. This enables faster realization of value during the transition towards a microservices architecture. Decomposing a monolithic application into microservices requires a well thought out strategy and approach. One important aspect of dealing is with data and databases. And here's how you can iterate on data to guide through this process. First, identify clear boundaries in your data that correspond to different business capabilities. This is typically related to the context of data, such as user management or order processing. Each of these domains usually corresponds to a particular business function and can potentially be a separate microservice. Look at how the monolithic application interacts with its data. Are there specific areas of the application that read and write from distinct subsets of your database? These access patterns can often help you identify natural boundaries for microservices. For each identified potential microservice, create a domain model to represent its data. This model should represent all the data that the microservice needs to fulfill its business function, but nothing more. It's important to ensure that the microservice has control over its own data and doesn't depend on other services for it. You may end up with duplicated data, which is usually an acceptable trade-off for the advantages that microservices provide. However, you'll need to decide how to handle data synchronization and consistency. Techniques like eventual consistency, compensation transactions with the Saga pattern, or using tools like the AWS Data Migration Service can help maintain consistency across microservices. One of the primary benefits of moving to microservices is the ability to enjoy rapid, independent release cycles. This agility can be compromised if your microservice has dependencies on a monolithic application. Strive to maintain independence of your new service as much as possible. Certain parts of your application, often referred to as hotspots, may be providing significant value to your business or undergoing frequent change. Such components could be suitable candidates for early extraction into microservices. Think about the e-commerce context. Consider extracting the promotions function before the buy function, since the former can be used as a dependency in the monolith's buy process. There may be capabilities within your monolith that are tightly bound to a central or sticky service. For example, user settings or configuration services. Strategically decoupling and transitioning these services into independent microservices can result in increased flexibility and scalability. When decomposing a monolith, focus on encapsulating business capabilities rather than extracting pieces of code. The goal is to create services that fulfill distinct business functions and not just position your code base. Start by identifying larger, more distinct business capabilities for those initial services, and then move towards more granular functionalities. But avoid creating too many tiny services, as this can lead to increased complexity in your service management and inter-service communication. Strive to design those services that encapsulate rich business logic and not just create read, update, delete operations. This promotes that domain-driven design, where each microservice models a specific business domain and contains both the data and the operations related to that data. Low coupling and high cohesion is a classic software design principle and is crucial in microservices architecture. Services should be designed in a way that minimize dependency and maximize the relatedness of their internals. This ensures that the service is self-contained and can evolve independently. Use APIs as a primary means of communication between services, and use events for asynchronous inter-service communication. This allows for clear separation of concerns and improves your scalability and resilience. Transitioning to microservices should be an iterative process. Start with a single service, learn from that experience, and apply those lessons to subsequent services. Iterating allows you to gain gradual experience and expertise, minimizing those risks associated with the transition. Try to ensure that each step in that decomposition process is atomic, meaning that it can be independently created without distributing or disrupting the overall functionality of the application. This approach reduces risks and allows for easier troubleshooting if problems arise. As you undertake this transformative journey, it's crucial to consider factors that extend beyond the confines of the application itself. In an environment characterized by a multitude of loosely coupled services, the role of observability in monitoring overall system health and performance becomes paramount. Furthermore, observability empowers you to make data-driven, value-centric decisions. So it's crucial to prioritize building robust observability mechanisms early in the process. Conway's law, a familiar concept to many, posits that a software system structure tends to mirror the structure of the organization that designed it. In light of this, to truly harness the benefits of migrating to a microservices architecture, it's imperative to reconsider your organization structure. Aligning your organizational design with your architectural design can involve transitioning to smaller distributed teams, which can work independently, much like the microservices they build. This kind of synergy between organizational and architectural structures is often the key to unlocking the full potential of a microservices-based approach. Our parent company, Amazon, serves as a prime example of successfully implementing these changes. The transition began back in 2001 when they introduced the concept of 2 pizza teams. This idea revolves around keeping team sizes small enough that they can be effectively fed by 2 pizzas, promoting agility and efficient communication. In this setup, each team takes ownership of a service, embracing the philosophy of you build it, you own it. This empowers teams to take full responsibility right from the development through to deployment and ongoing maintenance, fostering a sense of pride and accountability. These teams are also granted a high degree of autonomy, allowing them to make decisions rapidly without excessive layers of approval. This accelerates innovation and the time taken to implement changes or new features. Under this model, teams essentially operate as independent startups inside the larger Amazon entity. This unique structure promotes a culture of innovation, ownership, and customer-centric thinking, which has been instrumental in driving Amazon's success in the digital age. Next is adopting the DevOps principles by leveraging CI/CD pipelines, which can provide a number of advantages. The automation of mundane tasks through CI/CD allows developers to focus more on writing code and less on integrating features, running tests, and deploying applications. This not only improves efficiency, but allows for a higher standard of work, as developers can concentrate on problem solving and creating innovative solutions. DevOps and CI/CD facilitate more frequent and faster releases of new features and improvements. This ability rapidly iterates software, giving organizations a competitive edge as you can adapt quickly to changing customer needs and market trends. By automated testing in the integration process, CI/CD ensures that new pieces of code are integrated into the code base are of high quality. This contributes to the overall stability and reliability of the application and leading to ultimately a better user experience. More and more organizations are choosing to adopt a serverless first approach as they transition to microservices. This means that for every new feature or service, they first consider whether it can be implemented with serverless technologies. Serverless architectures provide many benefits, such as automated scaling, no server management, and pay-per-use pricing models, all of which align well to the principles of microservices. Whilst AWS Lambda is perhaps the most recognized serverless compute service, serverless technologies actually extend across the entire technology stack, from databases like Amazon DynamoDB to messaging services like Amazon SNS, and of course application integration like AWS Step Functions. Serverless can provide fully managed, scalable solutions for almost every layer of the application. Lambda functions provide key advantages like automated scaling and high availability. However, the real power of serverless becomes evident when you combine Lambda with other serverless services. Together, they can provide a comprehensive, fully managed, highly scalable solution for your microservices. One other key advantage of microservice architecture is that each service can utilize its own purpose-built database to its specific use case. In a monolithic application, all functionalities generally use the same database, which may not be optimal for all cases. In contrast, in a microservices architecture, each service can choose the database that best fits its requirements in terms of data model, query capabilities, performance, and scaling characteristics. AWS offers a rich collection of purpose-built databases to cater for a variety of use cases. For instance, we've got DynamoDB for key value workloads, Aurora for relational workloads, Amazon Redshift for analytical workloads, and many more. This breadth of options is rare to find in a single provider and provides a significant advantage. Whilst it may seem tempting to use a single versatile database, much like a Swiss Army knife, for all your use cases to kind of simplify management, it isn't usually the best strategy. Such a database may not provide the best performance, cost efficiency, or capabilities for your workload. And it's important to be skeptical of claims that one tool can effectively handle all use cases. The philosophy at AWS, and one that's shared by many in the industry, is that no single tool can be the best for all tasks. You should aim to use the right tool for the right job. This approach not only improves performance and productivity, but also enhances the customer experience and often reduces cost. In the context of microservices, using the appropriate purpose-built database for each service allows you to design that microservice to be efficient, resilient, and optimized for its workload. Now you've started to think about the microservice decomposition journey, you know some of the techniques, identified where to start, and you've looked at the possible compute and database options to support each microservice. You may have considered some organizational change to support the new model of delivery and put in the bases for observability. But you're still left with the technical job of wiring these services together alongside your monolith in a manageable way. Introducing the AWS Migration Hub Refactor Spaces. With Refactor Spaces, we've eliminated some of the most time-consuming design and implementation steps to set up best practices for multi-account Refactor environments. Once set up, we've simplified incrementally moving pieces of an existing monolith into microservices or safely extending the app with new capabilities. Previously, you might have spent months determining how to grow and evolve an existing application across multiple AWS accounts. This would be a time-consuming process where you'd architect how your legacy application and new microservices would need to communicate. Then you'd need to implement that infrastructure to make it happen. Now, with Refactor Spaces, you can provision multi-account Refactor environments in minutes that provide that cross-account network bridge for existing applications and new microservices to communicate directly. Once an application is in a Refactor Spaces environment, we provide a unified view of your application and new microservices using a Strangler Fig proxy. This proxy lets you incrementally route traffic to the new microservices without needing to learn and manage the complexity of multi-account routing. Using Refactor Spaces, you can quickly add new application capabilities in microservices without touching that existing application. This lets you accelerate the time to value when refactoring without the additional risk of making changes to that legacy monolith. Your teams stay independent and evolving applications is order of magnitudes faster. There are three primary benefits to the service that help you facilitate those incremental steps in refactoring. Using the orchestration service will reduce that time to set up and manage a refactor environment. The Refactor Space will shield your application consumers as you update and change the underlying infrastructure and microservices. And it allows you to seamlessly reroute traffic from the old monolith to the new capabilities across multiple AWS accounts. All of these allow you to refactor your application in days instead of months. Let's revisit our monolithic application and see how we can use Refactor Spaces to aid in its decomposition. Here we have a monolith that we've migrated from on-prem into AWS. During the migration, we already took advantage of some low-hanging modernization by moving our front-end React application to Amazon S3 and moved our database to a managed database in the form of the Amazon Relational Database Service. But we're still struggling to realize the full benefits of a modern application due to our monolithic backend. Through the processes we've talked about earlier, we identified the shopping cart as a key hotspot for our application and a good candidate for decomposition. And as we've adopted a serverless first strategy, we've deployed this into AWS Lambda and backed it with our NoSQL serverless database, Amazon DynamoDB. And because we've moved to having distributed teams, we're using an AWS account as a bounded context. So now we need a way to provide network connectivity between these accounts and VPCs, as well as routing based on the path of the user request. Let's walk through the basic app refactor steps in Refactor Spaces. First, you create the Refactor Spaces environment in an account that can be used as the environment owner. Next, we add in the other accounts to be used for refactoring. In this example, we have two accounts. One contains our existing monolith already in AWS, and the other is for our new microservice. Refactor Spaces has already shared a transit gateway with the other accounts, and it's now ready to bridge traffic between those three accounts. We add a default route to send all traffic to the monolith, and then we add specific routes for new paths to the Lambda function, and the external app users don't even know that the traffic is now being handled by a new microservice. Because we haven't removed the code from the monolith, we can use canaries or feature flags to allow us to gradually or segment-based send traffic to our new service, or even roll back if required. Under the covers, Refactor Spaces handled all the undifferentiated heavy lifting of creating an API gateway proxy, network load balancer, and transit gateway, leaving the team to focus on the functionality of their services. And because Refactor Spaces is orchestrating those services, it's not in your app's critical path. The availability, latency, and limits will be the same as those underlying highly available services. As we come to the conclusion of our discussion on decomposing the monolith with Amazon Web Services, it's good to reiterate some of the key takeaways. Firstly, decomposition techniques are a vital part of breaking down the monolith into more manageable, independent microservices. Remember to focus on extracting business functionalities rather than breaking down code. Secondly, adhere to the principle of low coupling and high cohesion. This encourages the development of services that are independent, yet work together in harmony, and the overall system is more resilient and adaptable. Thirdly, we must enhance our technical capabilities to support modernization, with a particular emphasis on observability. Transitioning to a microservices architecture introduces additional complexity in monitoring and troubleshooting due to that distributed nature of the system, and this makes observability a critical capability. Embracing a DevOps culture is paramount. CI/CD, infrastructure as code, automated testing, and other DevOps practices can speed up development, improve quality, and reduce operational issues. Next, always strive to pick the right tool for the job. AWS provides a rich set of services that can cater for various use cases, whether it's AWS Lambda for compute, Amazon S3 for storage, or a host of purpose-built databases. Picking the right AWS service can greatly enhance your performance, scalability, and cost-effectiveness of your microservices. Lastly, approach this transition iteratively. Breaking a monolith into microservices is a complex process, and it should be done gradually. Start small, learn from each step, and continuously improve your approach based on your experiences. As we embrace these key practices, we'll find ourselves better equipped to navigate the journey of decomposing the monolith, ultimately building systems that are more scalable, adaptable, and capable of delivering more value to our customers. Thank you for joining me today on this insightful journey. Let's look forward to transforming our software architectures together, utilizing the power and flexibility of AWS and the microservices paradigm. Thank you.